Hey Chan Physics, this is Mr. Block, and this should be a video for almost all the classes. This will be your day 2 for week 4. So you've just finished doing graphing, and we need to introduce you into conversions. Most of us will learn how to do most of our conversions in class, but we want to make sure that you have the skill set ready when you come in. And so there will be some homework for you to do at the end of this video, so make sure you watch to the end. Number one, why do we learn conversions? We probably think we remember doing some of that in 6th, 7th, or 8th grade. And they taught you one way to do conversions, and it was a great way to convert the metric system. But we're going to teach you a way to do conversions that is useful for any type of conversion. Meaning, how do I get, if I have something measured in feet, how do I know how many inches that is? Or if I have something measured in centimeters, 550 centimeters, how much meters is that? Or if I have a time that's in minutes, how do I know how many hours that is? And it's a great, great system to do anything to convert units. Now, what's more important than that is that it's going to be a system that you're going to use again in chemistry, and you're going to use it significantly. So we want to make sure that you know how to do it now, and so that you can hit the ground running when you get to chemistry, because you're going to use it a lot more in chemistry. You're going to use it a lot in physics. We're going to use it a lot more in chemistry. Okay, and so when do you use conversions? Well, I use them every day. Whenever I'm trying to figure out something, I'm going to use conversions. I use it as a way to think. My daughters have told me that they've used conversions 6 or 7 times on one ACT, so it's really important. But we've seen some examples of what happens if we do conversions wrong. And so some of you guys read about the Mars Polar Lander, where the thrusters were being, that data being given to NASA was given to them in pounds, and they were expecting it in a different unit, a metric unit. And then the Mars Polar Lander ended up being almost 60 miles off course. In the Tokyo Space Mountain, we see that they were taking what was built in the US, and so it had US feet and inches and things like that, and they were building it in Tokyo where they used the metric system, and so that particular train, the axle broke because it was not properly converted, and the train derailed inside Space Mountain in Tokyo. And one of my favorites, or one of the things that I think is one of the more dramatic mistakes when people were trying to convert, is the Gimli glider. And so in the Gimli glider, what happened was the plane was a brand new plane. They were loading it with fuel, and they had just decided in Canada to go to the metric system. And so the pilots were used to the gallon system, and they needed to convert gallons to liters. And they had a brand new computer system as well. And so the pilots did their best to load the fuel in correctly. But think about this. In the Gimli glider, the plane ran out of fuel, and it was up about 41,000 feet where it started to have problems and ran out of fuel. And so what I'm going to do is I'm going to show you a quick video of a documentary of what happened that day. And I want you to picture yourself being in this plane, because the plane is going to do some things that I don't know if I could ever really appreciate. But they're going to actually take this plane and glide it down and land it safely.
Well, like I said, everything was working fine. They were at 41,000 feet, cruising at close to 800 kilometers an hour when fuel pressure lights started coming on. There was no thought that we had a fuel problem, because we've done all these fuel checks, we're getting ahead on fuel, our flight management computers are showing we have lots of fuel. So actually, when I made an announcement to the passengers that we had some kind of a computer problem that we didn't understand, and then I was diverting the flight to Winnipeg.
And did you think any more of it than that at that point?
No, I didn't think any more of it.
Little did you know.
Little did we know, until the left engine failed.
Winnipeg, Air Canada, flight 1143. Canada 143, go ahead. Yes, sir. We lost power at number 1 engine. We'll require all the trucks out. 143, check, okay.
Captain Pearson throttles back, descending from 41,000 feet, changing course for Winnipeg.
I think it was 28,000 feet the right engine failed. The cockpit went black. We lost all our instruments and the lights. And I must have said something like, "What's going on?" And what's happening here?
With only basic hydraulics left to control the aircraft, Pearson contacted Winnipeg Control again.
This is a Mayday, and we require a vector onto the closest available runway.
I just said, this is a Mayday situation. We have no engine power.
Just so they were clear.
So they would alert them to the fact that, because they were, in my mind, they may not have understood the severity at that point of the problem.
The flight attendants told us to fasten our seatbelts, and I realized that something was the matter because they looked gray. They had frightened faces, so I knew from just looking at them that something was drastically wrong.
In the cockpit, First Officer Quintel frantically makes calculations and realizes Winnipeg is too far. The tower advises.
You're approximately 12 miles from Gimli right now. Where is it, on the right? On your right, about your 4 o'clock position. Do they have emergency equipment? Negative emergency equipment at all. Just one runway available, I believe, and no control and no information on it. And there'll be nobody on the runway when we get there, right? Nothing. I don't know. I can't tell you for sure.
Okay. And so this is the pilots. They are gliding the airplane down with very little power at all. And they're going to a runway that hasn't been used for years. Little do they know that there's actually a car race that has been going on that runway because nobody was using it anymore. That car race is over. But a number of kids are actually on the runway riding their bicycle. So as this plane is coming down, it cannot slow down. And so we're going to skip real quick to a part where we see the plane do something that is just out of the ordinary to slow down.
Flight 143 is still moving too quickly. No air brakes, Pearson decides to perform an old glider maneuver, turning the 132-ton aircraft sideways into the wind. Slow it down.
So you can see that this airplane to slow down needs to go from here, turns this way, and so the wind hits the side of the airplane to slow it down. And I can only imagine that the people inside of there were being just jostled and shaken up, and really it just does not feel right to be flying an airplane that way. Okay, and then we'll just skip right to the end of the video when the plane lands.
And his buddies were pedaling away when
we saw a plane coming across the horizon, and that immediately caught our attention.
Kerry's buddies hightail it out of there, but he is frozen.
And it's still coming in and getting bigger. The wheels touch down on the rear of the plane, and the front of the plane touches down, and the front landing gear gives way, and now there's smoke and spark up.
Okay, and so at the end, everyone survives, and right now they're talking about making a movie of that 37 years ago. That's what happened 37 years ago. So we have to learn how to do conversions, right? We see that this was an interesting problem, but why is it important to us? Well, we need to know how to do conversions for a lot of different things I think I talked to you about. And so it's going to be the last thing that we're going to learn before our first test. And we're going to take some time so that you guys get used to it. So first thing I need to show you is that you already know how to do conversions. And you already know how to do it in the way that we're going to teach you. And you have to say to yourself, well, wait a second, I thought you said this was a new idea. It is a new idea in that you've never written it down before, but you can do it in your head. And so let's figure out why it is that we know how to do conversions, and then number two, how do we then take that idea and put it in writing? Okay, so I'm going to ask you first if you can just think, and you said, if I was to ask you, if you had 3 feet, how many inches would you have? Right? So if you have 3 feet, how many inches do you have? And if we were in class right now, a majority of you guys would be able to get up and say, well, Mr. Block, I know for sure that's 36 inches. You'd know it. You'd know you were right, but you wouldn't know exactly how to tell me how to do it. And then if I had told you, if you had 3 feet, how many yards would you have? And most of the people who follow football would go, well, I know that's 1 yard. Mr. Block, I know that. Okay. So let's think this through. What if we were to draw that out? So here I'm going to draw 3 boxes, right? And we have 12, 12, and 12, right? Well, we have 1 foot, 1 foot, 1 foot, right? We know that that's 12 inches, 12 inches, 12 inches. And so in our head, we're like, oh, I know I just have to take 3 feet, and I know there's 12 inches in every foot, and that makes 36. Right? And that's what 36 inches looks like. It looks like 3 rulers back to back. Now, if we follow football, we know that there in every yard there is 3 feet, right? And that's the same distance, right? 1 yard looks like this. It's just 1 yard, and it's the same distance, right? It's not a little bit shorter like I've done here. I've made a mistake there, right? It's the same distance. So how did we do that in our head? And if we learn how we did that in our head, then we can create a system that we can use over and over again. And so what I can tell you that most of you guys would say, well, I know, Mr. Block, that in every foot, there's 12 inches, right? And so you see that if I was to take this 3 times 12, I get 36. Right? And you can see what I did was I took feet and I put it here on the bottom and I put inches on the top. I knew that I had to multiply, not divide. I knew I had to multiply. Somehow I just knew that. In here, right, when I do 3 feet equals 1 yard, well, then I would say to yourself, wait a second. I know that there's 3 feet in every 1 yard. Right? And so 3 times 1 divided by 3, and I get 1. And this is the beginnings of how we're going to learn how to make conversion factors. And the reason why we know that we can do it is we know that 4 divided by 4 equals 1. And we know that 5.4 divided by 5.4 equals 1. And so what we need to remember is that a foot divided by a foot equals 1. They cancel out. And so that's the most important thing, is we notice that when we look at our conversion, we cancel things out. We cancel the feet out, right? And then we're left with just a number of things. 3 times 12, 36 in inches. 3 times 1 in yards, divided by 3. So 3 times 1 divided by 3, we get 1. So we already know that. And so how did we do this? Let's learn how to build a conversion factor. So the way that we're going to do it now is we're going to take it and we're going to do a problem that we've never done before. Okay, let's do it in a way though that we know the answer. All right. So if we were to do a problem in the metric system and we'd say, all right, how many centimeters are there in 2 meters? Okay, and most of us know, at least, right, that there's 200 centimeters, or there's 100 centimeters in 1 meter, so there should be 200. So how should we go about doing this if we don't know that answer? And so what we do is we do a 6-step process. Right? First thing is when we have a conversion question, we take what's given to us and we put it right here, 2 meters. That's what's the given. And our goal is to find out how many centimeters, so we put a goal right there. That's our goal. That's step 1. Right? Step 2 is then build a conversion factor. So how do we build a conversion factor? Well, we put a line like that. And what we do for step 2 is we start by saying, we need to get rid of meters. And so we start with our units. We say, well, I know that I want to get rid of meters, so I need to cancel that out. So I'm going to put that down here. And I know that I want to get to centimeters, so I'm going to put that right there. Right. So now we have a set of units in a conversion factor. Now we just need to get the numbers. And this is what we've been practicing. And so we say to ourselves, all right, I need to find a conversion factor between meters and centimeters. And I ask myself, which one is bigger? Is it meters or centimeters? And most of us know it, but if we don't, we just go to our sheet and we go, okay, here is our base, centimeters right down here. Since meters is on the upper part, meters is bigger, right? And so we put a 1 in front of it. And then we go back to our sheet and we say, okay, centi is down here from the 1, 2. So that's 1/100th. And so we put in the 100 right there. Right, so now we've got our 4 steps. We've built a proper conversion factor. Now we can make sure that we're correct by making sure that we can cancel out units. And so if the meters cancel out, which they do, right? Meters divided by meters is 1, and that doesn't affect anything. And we're left with centimeters, which is what our goal was. So our last step then is just simply do the math. 2 times 100, 200 divided by 1, still 200. So we get 200, right? And that's what we predicted our answer would be. Let's take a look at it one more time, and then I'll give you the steps in a slide so that you can see it. So what if we wanted to do something like, how many meters are in 5 kilometers? Right? So how do I convert from 5 kilometers to meters? Right? So remember our steps are, number 1, we take our given 5 kilometers, we write that down. We write our goal over here, that's meters. So now we know what our goal is. That's step 1. Step 2, build a conversion factor. Now, step 3, we need to get rid of kilometers. So we're going to put kilometers on the bottom so that we can get rid of it. We have to get to meters, so we're going to put meters on the top. And now we need to put in our numbers, right? And so we say to ourselves, which one is bigger, kilometers or meters? Kilometers is bigger. So I'll put a 1 in front of it. I go to my yellow sheet and I say, what's my number for kilo? Well, here's base 1, 2, 3. So 1,000, right? 3 zeros. So there's 1,000 meters in every 1 kilometer. Right? And now we're ready to do our math, and we'll say, we gotta get rid of our kilometers, right? Because they cancel out. We're left with meters, which is what we wanted. And now we just have to do the numbers. 5 times 1,000 divided by 1, and we get 5,000. All right? So let me just make sure that I do the problems that I've got up here. We're going to do some examples. So here's our steps. And so you have it in a slide. Step 1, write down your given. Step 2, create a conversion factor, which is just write down a line. Step 3, write down the unit that you're converting from, the one you want to get rid of. Put that on the bottom or the top, depending on which way we're doing this. You'll see that sometimes we're going to start out, they're always going to be on the bottom, but eventually we're going to show you that you can convert things in a different way. So we just say we put it on the opposite side. Step 4, we put the unit we're converting to on the other side. Step 5, we ask ourselves which one's bigger. We put a 1 on it, and then we go to our sheet, and we do step 6, we get the number. Once we have that conversion factor ready, then we'll just do the math by canceling out the units. Okay. So I have 3 examples that I want to do. We just did 1, 5 kilometers to meters. So let's just take a look at that one on the camera. Okay, we just did 5 kilometers to meters. Right? We wrote down our given. We wrote down our goal over here. We created the conversion factor. Right? We want to get rid of kilometers, so we put it opposite. We wanted to go to meters, so we put it here. we ask ourselves, which one's bigger, the kilometer, and then we put the number in. So let's do 2 more examples, and then we'll give you guys some homework. So the next example that they ask us to do is 355 centimeters to meters. And so how do we do 350 centimeters to meters? Okay. So step 1, write down our given, 300 centimeters. Write down our goal over here. That's what we're trying to get to. Step 2, build a conversion factor. That's just simply drawing a line, right? Step 3, we want to get rid of centimeters, so we put centimeters opposite. We want to get meters, so we put that up here. That's step 4. Step 5, we ask ourselves, which one's bigger, meters or centimeters? We put a 1 in front of the bigger one, that's meters. And then we go to our yellow sheet. What's our number for centi? 100. And then we can do the math, which means we can cross out the units that we can get rid of. And now we can do the math, which is 350 times 1 divided by 100, right? 350 times 1 is 350 divided by 100 is 3.5. So there's 3.5 meters in 350 centimeters. All right, last one, and then I'm just going to leave you guys with 3 to do for homework. So the last one they do is 1.2 meters to millimeters. How do we do that conversion? And so here it is. I'm going to get a new sheet of paper for us. Hopefully one without a lot of dots on it. Okay, 1.2 meters, and they want to know how many millimeters that is. Right? 6-step process. Take what we're given, write it down, 1.2 meters. Take what our goal is, put it over here, millimeters. Right? That's step 1. Step 2, build a conversion factor. Step 3, we want to get rid of meters, so we put that opposite of our given, right? So we can cancel it out. We want to get to millimeters, so we put that on the top, right? Now we're at step 4. That was step 4. Step 5, right? Which one's bigger, meters or millimeters? Meters the base, millimeters way down on the list, right? We put a 1 in front of the bigger one. We look at our yellow sheet. We know that milli is 1, 2, 3 steps down. 3 zeros, right? And we get 1,000. All right, that's our 6 steps. Now we can just do the math. First math is cross out those units that we can cross out. Meters divided by meters will cross out. And now we can multiply 1.2 times 1,000, put it in our calculator, divided by 1, right? And we're going to get 1,200 millimeters. That's how we do a 1-step conversion. It's just the basis of how we're going to do. We're going to learn how to do multiple step conversions. We're going to learn how to do conversions between the metric system and the US system. But this system, as long as you know how to do what I just taught you, how to use the 6 steps, you can build any kind of conversion, and you can do every kind of conversion that's necessary. And then when you get to chemistry, you'll know the system when they use this idea to do something much different. Okay? And so the last bit of this video is I'm going to turn off the camera, and I'm going to give you some homework. And this homework is just going to be simple. Open up your notebooks and do these 3 conversions. 150 meters to kilometers, 358 centimeters to meters, and 451,000 millimeters to meters. Okay? Remember the 6-step process. If you want to go back in this video, right, I have the list right here of your steps 1, 2, 3, 4, 5, and 6, and then you do the math. Or remember the setup always is write the given down on the left, write the goal on the right, and then start building your conversion factor. All right, we will be looking when you come back to class, for these 3 problems to be done on a sheet of paper so we can look at it and that we can build on this idea. Good luck to you guys, and I will see you A or B whenever it's time.